Welcome to Talking Kotlin. It always cracks me up because they don't see this off stage. I keep counting us in. Hey, Seb.
Hey, how are you? The amount of infrastructure work we do to try and get this show on the road is always it's a lot. It's a lot of discussion to just figure out who says hello.
Especially on the road part. We're always on the road. You know what? I look at your shirt and I'm like, Aruba, Jamaica, come on, won't you take her to Bahama, Bermuda? No, it's the other way around.
Oh no.
You are so summery. Is it like summer in Munich?
No, I have this idea that if I wear Hawaiian shirts for long enough, that summer will have to come automatically. It won't have another choice.
Oh, I thought it was for me to sing you Beach Boys.
I mean, also, sure.
That
it's
works
always
as well.
Delightful.
I just went swimming and it's raining outside. I'm like, screw it. Let's go swimming. So I just went swimming.
Well, I'm glad you didn't get struck by lightning or something.
Why? So you would do the show alone? No, you're just trying to kick me out. Every freaking week, you're trying to kick me off this show. And now it's just like, oh yeah, I hope you get struck by lightning. Fine, it's okay.
That is not what I said.
You're not going to get rid of me that easily. Sorry, you were saying.
Hello, everyone. Welcome to our YouTube audience, our SoundCloud audience, and wherever else you are listening to this podcast. Today, we have a wonderful guest. We are joined by Matt Anger, who's a senior staff engineer at DoorDash. Welcome, Matt.
Hello. Thank you for having me here.
Thank you for coming on.
It's really sweet to have you here. So, Kotlin and DoorDash. Do you want to give us a short intro about what we maybe can talk about today in this context?
Sure. I mean, at a high level, basically, DoorDash has gone all in on Kotlin. We're rewriting the Android app in Kotlin. We're rewriting all of our new backend services in Kotlin. As we migrate away from our monolith, which is an older Python Django stack, we are kind of going all in on Kotlin as the language that we want to use.
So before we dive into all of that, let's maybe just for the few people in the audience that may not have heard about what DoorDash does, do you want to give the elevator pitch? I know Hadi loves elevator pitches.
Yeah, I mean the elevator pitch is really that DoorDash is your last mile logistics company. It's most people know us for our consumer side, which is food delivery, but we also do other last mile delivery for businesses as well. So the main thing is that within your city, if you need to get something from point A to point B, DoorDash can help.
Sorry, I had to laugh just there because I saw you said most people know us for our consumer products, and today I saw a tweet about how Amazon had purchased MGM, and someone had said, "Oh my God, so Amazon owns RoboCop now." And when you said consumer products, I'm like, but on our side business, we also do robots. Killer robots. No, yes, but we don't use Kotlin in those killer robots, do we?
DoorDash is not involved in any sort of killer robots, no.
It's just the way he said, we do consumer products and killer robots. Right. So I'm actually excited to have you on the show because Backend, right? When back in the early days when I started the show before Seb took it over, we used to talk a lot about Android, and people were like, "Oh, when are you gonna have some backend stuff?" And when I saw your blog post about how DoorDash has adopted Kotlin on the backend, I was like super jiggly. I don't know if jiggly is a word, but I was like super jiggy, and I'm like, we got to get Matt on the show and talk a little bit about this. So right off the bat, did it start with Android or did it start with server side at DoorDash?
I'm trying. I think we actually had the Android team moving first, honestly. So it was kind of like the Android team. They wanted to do their thing, and then the backend team was kind of like, okay, it's time for us to start breaking up our monolith. What do we choose? But the Android team had already started their rewrite.
Then maybe the question that's burning on everyone's mind is then why Kotlin? Why did you end up choosing Kotlin? I mean, great choice, but why?
Yeah, I mean, for us, we really came down to a couple of factors, right? We were trying to find what language can we have that's gonna scale with the company, scale with our increased number of requests per second, and just give us the right amount of developer productivity for the performance that we trying to balance those trade-offs. And for us, the reason why we chose Kotlin was mainly because in our minds, we think of it like a better Java, right? Like that's at a high level. That's how we came down to it. We can interop with the entire JVM ecosystem. We can use a lot of the libraries and a lot of the integrations that we already have, right? We use Cassandra, we use Postgres, we use Kafka, all these things that have great Java and JVM integrations, and we can still use all those and use them natively with Kotlin while getting some of the benefits of a slightly nicer syntax, some more functional aspects, immutable by default. So some of these things that you get in the Kotlin ecosystem. And then on top of that, coroutines, which we use heavily for a lot of our services to make our asynchronous programming look a little bit more in the kind of imperative style that a lot of our engineers are used to. So at a high level, that's really what it was. It was for us, it was the better Java.
But your background was, or at least the server-side stuff that you were using in the past, the language was Python, right? And how was that change? I mean, Python is a dynamic language, a static language. How did the team embrace that?
It wasn't actually too hard, right? A lot of our engineers already had experience with statically typed languages, be it C++, be it Java, be it and so it wasn't too hard for us to kind of transition them over and start thinking in Kotlin and start thinking in this. And basically the hardest part was actually more teaching them to adopt some of the functional aspects of Kotlin. Right, having them deal with types wasn't as hard as it was. Okay, let's look at functional. Let's look at immutable by default. Trying to ingrain some of those kind of behaviors into them was actually the harder sell.
Okay, as a complete new op to Python, there aren't higher order functions in Python, and it's not very functional in that sense, or you just weren't using it.
I mean, we use some of those, right? Like for comprehensions and things like that. And you can have single line lambdas in Python. But obviously thinking immutable by default, right? Make sure everything is immutable by default as you pass it through the stack so that you don't have to deal with, sharing across threads and things like that. That's really not a thing in the Python world, right? Things can be reassigned, things can be modified at any time, right? The idea of immutability is sort of an oddity in the Python world, right? You have to manually declare it as a frozen set or a frozen map and things like that. And in Python, it's in Kotlin, your maps are immutable by default. Your lists are immutable by default. Your sets are immutable by default. And so, teaching them to think that way and, getting away from the declaring a variable and then maybe having some if chain or a switch chain that determines its final value and using the more functional aspects, right? Where you can have an immutable variable and it can be assigned to essentially almost like a lambda or like an if statement or a case statement. Teaching them to use that behavior versus, declaring it as a var and doing it the way they used to.
How did you actually teach these kind of changes to your team? Is this something where you did a couple of courses, or you're doing trying out pair programming, code reviews? What was kind of the main way of switching there?
We did a little bit of all of that, right? So we did we call lunch and learns, where we kind of do 45-minute basically having a senior engineer or someone who's an expert on a particular field kind of do a small presentation for 45 minutes over lunch. And we have those 2 to 3 times a week, depending on how many people want to speak. So we did a lot of those. We have a series of internal kind of Kotlin best practices, trying to teach people, okay, this is how you should think of things, showing them examples in the, we've seen these bad practices, try to avoid vars and stuff like that, and then showing them how to kind of directly translate that behavior. We also heavily use linters that kind of try to detect a lot of the stuff for us, right? There's a lot of good, versions of KTlint and detect, and we use kind of slightly different ones in different repos, but trying to detect things bad formatting. They have some nice code smell, they call it, lints that they can try to detect for us. And so heavily in pushing those throughout our entire code base to help try and, detect some of these things and catch them without relying on humans to do it all for us.
And you said that the architect, you were kind of combining this. So you were combining the change of architecture and the change of language at the same time. Did you feel that was an additional challenge, or did you feel that Kotlin actually maybe made this easier?
I don't think it was an additional challenge, right? I mean, we were going to have to rewrite everything as we were moving to services anyway. So we may as well take the time to look at, okay, well, what makes sense for us to do the rewrite, right? We don't necessarily just want to copy paste the code that wasn't our own monolith and just kind of put it somewhere else, right? Like that's not going to lead to a good service experience. We're going to have to deal with a whole bunch of issues that we don't want to deal with as we, start moving things away from like all talking to the same database, all being in the same code base, right? You can't just copy paste anyway. You have to rethink and re-architect your services as you're breaking apart your monolith. And so it wasn't necessarily any additional challenge kind of moving that to a different language.
So you had a big monolith in Python, essentially, and you decided to go full out, not only change language, but also change architecture, move to microservices, I guess, in this sense. And looking through the blog post, you make use of interesting set of technologies. One of them is, I didn't even know about this. Seb, we got to get these folks on the, I don't even know how you pronounce this. Is this Proto Plus? And Protocraft. Okay, what are these?
Basically, these are sort of Kotlin enhancements to the grpc and the protobuf ecosystem. So for the long time, traditionally, when you wanted to use protobuf for grpc in Kotlin, you had to use the Java bindings, which don't necessarily behave the best in the Kotlin world. They look a little funny, right, with the way they do the builder pattern and some of this stuff. And so these are two open source libraries that we use in combination to kind of build a much more Kotlin native experience for our grpc and protobuf integrations. So you can use this stuff, and then you were able to get like suspendable function handlers for your services that implement grpc endpoints and things like that. Obviously, today we now have grpc Kotlin, and so we're rapidly migrating kind of away from those into the native grpc Kotlin. But prior to grpc Kotlin's GA, which was just earlier this year, these two libraries basically helped us turn the grpc Java and the protobuf Java into much more Kotlin-friendly, Kotlin-native integrations.
That sounds really useful, actually. We'll definitely add those to the show notes. And by the way, I'm not sure if we actually mentioned it. Hadi said he was looking through the blog post. We're probably going to link that blog post in the show notes as well if people want to check that. I think it's like microservices is a really hot topic for people just as like an architectural pattern. And I don't think it's any different if we're looking at Kotlin for server side. Do you have any kind of like general like tips and tricks for people who are looking into building their microservice architecture with Kotlin specifically? Some patterns you want to recommend maybe?
I mean, I think one of the biggest things that I think, especially as if you're moving from a monolith to services, one of the biggest things I think to make sure you get right is understanding where you want to draw those boundaries. And if possible, you can start to enforce those boundaries in your monolith first, so that you can kind of understand where those cross points are. So you can make sure that you're extracting the right thing. I mean, we don't go full what I would consider microservices, what some people consider microservices. We kind of have like service domains is the way we've kind of split things out, where we kind of have, think of like a bunch of mini monoliths, where we have like a set of services that are all tightly coupled, that are responsible for like some of our geo tracking things. Or we have a set of services that are, tightly coupled, that are all responsible for the logistics side of our platform. And being able to kind of split those domains out within your monolith and having those kind of tight service boundaries will really help you as you're doing the migration. Because then you can, if you hide some of the stuff around behind like classes and functions, then you're just modifying one code piece. When you're saying, oh, this becomes, instead of just some raw database call, now it's a grpc call to some other service. You can easily, shade traffic back and forth and do traffic replays and stuff like that. So I think that's the biggest thing that I always recommend is like try to enforce some of those boundaries that you're gonna eventually become services in your monolith first. And then from there, as you're doing services, the big thing is just having a good way to kind of communicate between those services and understanding where the failure points of those are, right? Oh, I was gonna say that some of the big things people forget is like they don't build in circuit breakers. They don't build in, retries and backoffs. And then when you don't have some of these features, when you're talking service to service, you often end up with what is traditionally called like the stampeding herd problem, where if one service has a hiccup, suddenly if you don't retries with backoffs, suddenly you start slamming, you take down like your entire fleet of pods, which is not helpful. You're not really getting any of that resiliency you were hoping to get from a services architecture.
I was going to ask, what server-side technology did you actually use in terms of the framework? Is it Spring-based or is it something else?
Right now, we have a little bit of everything. We weren't very prescriptive in the very beginning as we split out our services. And so we have a mixture. depending on kind of what the different tech leads on the various teams chose. So we have some Spring, we have some Micronaut, we have some that just kind of use grpc netty and like use something like Google's Juice dependency injection framework to kind of build the services up. Going forward, our dev prod and Kotlin platform teams have been focused on building what we call like our next generation base server, which is using a framework called Armiria. They're using Armiria from the folks over at Line and Juice as a dependency injection framework. And going forward, all of our services will be based upon that.
Line is the company in Japan you're referring to, no?
Yep. Yeah, the chat platform company.
Yeah, awesome people in there once. Nice. I hadn't heard of Armiria. That's another one we've got to get on the show, Seb.
Yeah.
Are you taking notes, Seb?
Sure. Always. Mentally.
Always, right.
So how did you actually end up then choosing this library as like the base for your new services? Was there a particular reason?
So there was a couple of things that really attracted us to it. One is its ability to serve both gRPC and HTTP off of the same port and same event loop, which is useful for us because obviously, like I said, for service-to-service communication, we rely on gRPC, but we've also been migrating to Prometheus for our metrics. And so for Prometheus, right, generally you want to have a HTTP endpoint, which outputs the metrics that you have a scraper that can then parse. And so rather than having to split up like a second event loop in all of our pods, Armiria lets us serve both of those kind of off of one event loop. On top of that, we had already started adopting Armiria for the client side. They have some really nice client-side integrations for gRPC and HTTP that we had already started using outside of this to provide, better gRPC clients with a lot of our defaults and a lot of our interceptors that we had written over the years pre-baked in. And when you use the client and the server side, they have some nice integrations that go well together. They can help propagate some error information back and forth so you can do debugging easier if there's a failure or anything like that.
And in this awesome blog post, which I like, this is for people. You see, if people aren't aware of this blog post, they don't need to read it anymore because we've got this show. But if you have read the blog post, well, you should be watching the show anyway. But you talk about some of the gotchas, right? So generally, you're happy with Kotlin, but you talk about some of your pain points. What are these pain points?
So some of the pain points we've had is one is what we call the phantom NIO libraries. And so when we're talking with Java libraries and we're using sort of, wrapping some sort of Java library to do maybe a database access or something like that, some of these libraries that have claimed to support kind of NIO natively weren't really doing like using the Java NIO primitives. And so they're essentially kind of like thread pools on top of block. And that's how they provided that, completable future style interface. And the problem that we ran into was with these kind of libraries, if you're spinning up a lot of coroutines and doing kind of like the map complete all style of approach with a lot of these coroutines, is it would cause their thread pools to explode. And then that would cause a massive increase in memory usage on our pods, which would then get killed because they'd run out of memory and things like that. So we had to kind of curate a list of kind of libraries that we've worked with and that we know how to tune appropriately, or that we know implement like kind of NIO natively, so that we can use them with our coroutine style architecture and not experience that explosion in memory usage due to like spinning up a ton of threads. Another one that we're still dealing with today is sort of just kind of how, I guess, Gradle does dependency resolution. We've run into it a few times where, like, by default, Gradle likes to just kind of up versions to the latest version it sees in any of your transitive dependencies. And sometimes libraries don't necessarily like that. So part of what we're doing to help fix that is internally, we publish kind of a bill of materials, a BOM as part of our new server base that ties a whole bunch of these library versions together that we provide work. And part of that so that, we don't run into these issues where, some transitive dependencies messing up the chain, but also it helps us solve, like, if there is a security concern with a particular version of the library, we update once in the BOM, make sure that it works everywhere, and then everyone just kind of gets that automatically. Rather than having to go through each and every individual teams and like upping the version in all their libraries. So it's like, no, just up the BOM to the latest version and you'll get all the list of changes with all the security fixes and things like that.
Is it a challenge? Is the whole Gradle Maven thing a challenge? I mean, but JavaScript even has a build system. I mean, they call it packages.json, where they've gone from just managing packages to also telling it what to do. No, so isn't there something similar in Python where you can like do steps of what to do next?
Not so much in Python. In Python, generally, you have like a requirements.txt. You do a pip install with the requirements file. It installs all your dependencies with whatever version you've told it to, and then you just call Python and like your main.py.
So how did they find Gradle?
I mean, it's like I said, it's been challenging, right? The biggest issue has mainly been around like libraries that we have that are shared, or that we try to release common libraries. And if you update the version in any one of these, and some down libraries or some other teams haven't necessarily updated to try your latest changes, we have to kind of work with them at times to figure out, okay, how do we get this? Which is why I said like we're publishing this bomb going forward to help kind of eliminate this, right? We'll tie all the versions together for our common stuff, and it will take care of providing compatibility where we need to. And you just rely on importing this bomb and let us specify the versions of your underlying packages.
Right, but apart from the dependency management, they didn't really find Gradle itself challenging, or the concept of having to do these build and defining the configuration blocks and all of these. Nothing. That was all good.
I mean, for the most part, we hid a lot of that stuff from them. So we actually have a script that generates the base repo with a Gradle file, with a Docker file, with scripts for our CI and CD pipelines. So for the most part, they don't even really see a lot of this stuff. We also give them a make file, so they can just type make build, and we'll run the appropriate Gradle command with the appropriate environment variables and things like that. So we hid a lot of that stuff from them to make it as easy as possible.
But it's very clear that you folks have bought really deeply into the whole ecosystem, which I think is really exciting. So going forward, are you folks planning on keeping all of your services in your microservice architecture in Kotlin, or do you have like a heterogeneous architecture in mind with some other languages in the mix?
It'll likely be like 99% Kotlin. There'll be a few one-off services here that for a variety of reasons may be in another language. For example, we have some Go for some certain instances where we have, or things where we're interacting with, like say the Kubernetes API. We also have some Scala for some ML AI and like batch big processing, really where you have like where Scala is super useful in that scenario. But most of our services are going to be Kotlin.
And just to correct what Seb said, he said collection of monoliths, not microservices.
Did I?
No, no. Matt said, you said a collection of like small monoliths, right?
Small monoliths, yeah.
Small monoliths, right? So knowing what you know now, what decisions would you have made differently? Apart from not coming on this show.
Like I said, the only things that kind of we would have probably done earlier would have been probably publishing the bomb from day one, right? Just kind of getting that set up and having teams kind of tie together what versions we're using would probably have solved quite a few hours of headaches that we've had to deal with at times. But like other than that, for the most part, we're super happy with it, right? It's scaling extremely well for us. We've gotten our QPS on a per core basis, moving to Kotlin and setting these things up. We're seeing better reliability. So overall, we're extremely happy.
Okay, I have another question for you. Sorry, Seb.
No, go ahead.
Now, I want a real honest answer from you. How do you find the tooling for Kotlin in terms of the IDE?
Do you want me to be completely honest on that?
I want you to be 110% honest on this.
I have mixed feelings about IntelliJ. Honestly, in times it is extremely useful and it's extremely powerful. I've used it outside of Kotlin in personal projects for Go, for Rust, and stuff like that, and it can be very powerful. It is obviously a very heavy process with everything that it comes in, right? When you boot it up, for most of our projects, we have IntelliJ set up to take like 8 gigs of RAM as soon as it boots up, just to deal with some of our larger projects. It is a little bit more CPU heavy than other ones. The main thing that I would love if the Kotlin ecosystem had, I guess like a language server would be great. I know there's like a one third-party one, but sometimes like I don't necessarily need or want to boot up the entire IntelliJ to make a quick change. I'm a little bit old school. I have a very complicated Vim setup that builds a whole ton of stuff, and so sometimes I just want to open Vim, quickly make some changes, and it'd be great to have at least some basic code completion and stuff like that built in. That's something that I would love to have. Overall, I mean, IntelliJ works pretty well. Occasionally it has hiccups where it's like, well, I guess you just have to restart it. And like that's kind of what you have to do every once in a while if it's not pulling the right environment variables, for example, for like our credentials for our personal artifactory or things like that. But for the most part, like I said, it's extremely powerful. Its ability to refactor things is really well. But it is a little heavy in terms of like what it takes on your system.
Okay, I mean that's interesting because I was thinking if you have any issues in terms of refactoring or things like that where you felt it wasn't on par with Java, and generally all of the team use IntelliJ, or there's folks on Eclipse or other systems.
No, everyone uses IntelliJ. Yeah, we don't have anyone using Eclipse or anything like that. Like I said, there's those of us that are a little bit more old school, where we're occasionally hopping into like Vim and whatnot. But for most of our developers are just using IntelliJ on their day-to-day.
But you just gave me a brilliant idea, right? People always ask, like, what is the right size for a microservice? We could just define it, whatever fits into IntelliJ. I'm just so full of good ideas today. Anyway, Seb, you wanted to say something?
So Kotlin still evolves quite quickly, I think. Are you folks like always on the bleeding edge there, always using the latest versions, or are you taking a bit of a more conservative approach?
It kind of varies. We already have some services migrated to 1.5. And we've been fairly happy with it. We do have some older services that just haven't migrated that are still on like 1.3. In particular, the 1.3 to 1.4 shift, where you guys changed some things around serializable, has been kind of painful for certain teams. But for the most part, we try as much as possible.
And looking at kind of the way that the language and the ecosystem kind of evolves, is there any particular topic that you are specifically looking forward to, or that you can't wait until a version of it gets released?
The one thing that I would love is if we kind of had the coroutine everywhere kind of view of the world, which I don't know if that's on any roadmaps, but you can imagine similar to kind of like what Rust has had now with like async main, or what you get with a Go program, where you just kind of have natively coroutines everywhere, and you don't really have to think about, is this function in a suspend function or not? Do I need to call, threadpool.execute and like pass it off and then get the future and stuff like that, where just kind of like everything was suspendable by default. Like I said, so similar to what you get kind of with the Go world, where I can call Go functions and I can call blocking functions anywhere I want. And to have that kind of behavior, I think would be kind of cool and kind of useful to have that, where like everything is async.
That's interesting. I have to admit, I have not heard that one before. Maybe Roman is listening in. Maybe he'll use this as inspiration and he'll thank you in a bit. I don't know.
Seb, I hate to break this to you, but this isn't a live show. Roman isn't listening in.
Well, what do you mean? Like, he can still listen to the recording.
By the way, Matt, on a side note, if you do have performance problems, really, with IntelliJ, send us memory snapshots. We'll fix it. Promise. Okay, no, I'm not going to promise, but we'll look at it. Right? Really, we'll try and fix those.
Yeah,
we will. Seriously, send it to us because if there's shortcomings in the refactoring and all that, we're getting to it. But performance problems, we want to try and fix as soon as possible. So please do send us that. We want to make your microservice as big as a monolith possible, right? Really big.
Yeah.
Cool. So what's next for DoorDash, and what's next for Kotlin in terms of what you folks are doing? What do you have planned?
Like I said, we're still fully pulling apart our monolith, so we'll have more services coming up, finishing all those extractions and kind of getting forward. And then the next thing will be migrating all of the services to this new service space that we've been talking about, right? This Armeria-based framework, and kind of getting that rolled out everywhere, where we have this common framework that's powering all of our services with distributed tracing and Prometheus metrics and all those wonderful things enabled, so that we can really understand kind of everything that's going on.
Well, I think we're actually out of time for this episode. So before we say goodbye, are there any more topics, like maybe open source projects or something that you want to shout out specifically for DoorDash in combination with Kotlin?
I don't think so. Like I said, we've interacted a little bit with some of the open source ecosystems, and we're extremely happy with it. Right? We've had some things upstream into, like, say, the open telemetry work streams and stuff like that, and it's been great. So the whole ecosystem is just a pleasure to work with.
Cool. Then thank you so much for coming on the show. I think we've learned a lot about Kotlin, about microservices, and about DoorDash. That was a really interesting combination of topics. Yeah, and thanks for coming on.
Awesome. Thank you guys for having me.
Thanks for coming on.
All right. Take care.
Take care. Bye-bye. And for everyone else listening out there, we hope you enjoyed it, and we will be back next time. Don't forget to
hit that bell, like, subscribe. Did you get the bell fixed?
I hit that notification thing. No, I didn't. I hit that notification thing on some other channel, and the damn phone the other day vibrated saying there's a new video.
I mean, that's kind of the point.
Oh, then switch off that notification. You don't want to be interrupted that there's a new video of Seb and Hardy. Oh, we should change the name of the show. We should call it the Seb and Hardy Show. Are you too old? Are you too young to watch The Simpsons?
No, I'm not too young to watch The Simpsons. Maybe that's going to be the intro in the next one, though. We'll see.
Sebby and Hardy Show. See you next time.
Take care, everyone. Bye-bye.
Bye-bye.